Welcome to Internet Infrastructure Explained.
Imagine a bustling digital highway where countless data packets travel every second. How do network engineers ensure that different types of information, like sensitive financial data versus routine web browsing, can coexist efficiently without interfering with each other, even on the same physical cables? This challenge is at the heart of modern network design. The 802.1q Tag Protocol Identifier, commonly known as TPID, is a crucial for byte field inserted into an Ethernet frame. Its primary role is to signal the presence of virtual local area network, or VLAN, tagging information. Essentially, it tells network devices that extra data specific to VLANs is attached, enabling the sophisticated segmentation of virtual networks. The need for the TPID emerged as networks evolved. Early Ethernet frames were simpler, but with the growth of complex infrastructures, the ability to divide a single physical network into multiple isolated logical networks became vital for security, performance, and streamlined management. The IEEE 802.1q standard introduced the TPID specifically to identify these VLAN-tagged frames. Without this unique identifier, standard Ethernet devices would simply discard the additional VLAN information, unable to interpret its purpose. The TPID acts like a special flag, alerting switches and routers that a for byte tag containing VLAN identification and priority data immediately follows. Its fixed hexadecimal value, typically 8100, allows network hardware to quickly recognize and properly process these specialized frames. In practical network operations, when a switch receives an Ethernet frame, it first inspects for this TPID. If the TPID is present, the switch understands that the subsequent for bytes carry the VLAN tag, which includes the VLAN identifier and the priority code point. This vital information empowers the switch to accurately direct the frame exclusively to other devices residing within the same virtual network, effectively isolating traffic. Network administrators leverage this mechanism to establish distinct broadcast domains, significantly boosting network efficiency and bolstering security by preventing traffic from one VLAN from traversing into another. While 8100 is the most common TPID value, some service provider networks employ a more advanced technique known as Q&Q tagging, or IEEE 802.1AD. This involves encapsulating an existing VLAN tagged frame within another VLAN tag, essentially adding a second TPID and VLAN tag. This nested tagging extends VLAN capabilities, allowing customer VLANs to seamlessly traverse a service provider's VLAN infrastructure, creating an extra layer of segmentation for enhanced scalability and multi-tenancy. Grasping the function of the 802.1q TPID is absolutely fundamental to understanding how contemporary switched networks achieve their impressive virtual segmentation. It is the silent, yet incredibly powerful, signal that enables VLANs to logically separate diverse traffic. This boosts network performance, significantly enhances security, and greatly simplifies network administration across even the most complex and expansive infrastructures. This seemingly small identifier is truly a cornerstone of modern virtualized networking.
If you love understanding how the web works, like, subscribe, and stay connected with us.